This was chaired by myself and Rainier Stotska. It was one of the 4 original working groups in the Research Data Alliance. Going to the next slide. Herman, can you change the slides then? So I haven't seen the extra slide that Herman added. I'm on the slide now called Policy Topics. And so I'm going to assume that Herman will advance the slides as I go through here. For the topics within the Practical Policy Working Group, we wanted to focus on the issues related to policy-based management of data. And in particular, we focused on data center policies. We wanted to compare the types of policies that groups were using in production environments and see if there were any common sets of policies that everyone was interested in. We then, after looking at the data center policies through the Research Data Alliance, extended the work by considering policies from 6 additional areas. For groups doing research collaborations, digital libraries, for groups managing protected data, groups doing preservation, and groups trying to do National Science Foundation style data management plans. Next slide. An example of a group, a data center that's applying policies, was provided by the KIT Data Manager. They had the challenge of registering data sets, permanently storing them, making the data sets accessible and retrievable, and curating the data by adding contextual metadata, provenance metadata, descriptive metadata. So they needed a way to define all of the information they wanted to associate with each file, in addition to managing the files themselves within a distributed environment. Next slide. The approach we took in order to understand how to do policies was to define the set of tasks that we wanted the system to automate. We wanted to avoid having to do any manual activities related to the management of potentially millions to hundreds of millions of files. So a policy allows us to define the type of operation we want the system to perform, and there turned out to be 3 types we needed to consider. In most cases, we had to set policies for defining the environment in which the data were being managed. Where are the storage locations? What's the authentication mechanism? How are we naming the files? We had to define policies related to controlling the operations we wanted to assign to a file. And we had to define policies for verifying that the system was working correctly. These could be generating reports, tracking the usage, tabulating the amount of data that was stored at a given site. The next question we asked is, given these sets of policies we have to implement, is there a generic template we can use to define one of these policies? And it turned out that for the cases we looked at, there was a generic template. We needed to define the state information required for the execution of a policy, the variables that the policy would use as input. We had to define the policies themselves, what type of control mechanisms they needed to exert, and then we had to define the operations that would be controlled by the policy. Next slide. So this is a question I'd like to get a consensus from the audience. Which is more important, controlling the user interactions, controlling the property of the collections, or controlling the interactions with the technology in which we're managing the data? So I'll give you a minute to come up with a consensus. And so far I see 5 responses, 8 responses, 9. But it looks like the highest interest right now is in controlling the collection, with 3/4 of the people, responders, stating that this is the highest interest for them. So when you're controlling a collection, You have to manage the naming of the data within the collection, the organization of the files in the collection, a collection hierarchy, descriptive metadata, provenance metadata, its authenticity, where did the data come from, integrity. You could have properties related to retention, distribution, properties related to required data formats, etc. So there are many properties you can associate with a collection that you want to enforce as you bring in new items into the collection. Next slide. So to summarize the effort done within the Practical Policy Working Group, we wanted to enforce management of the collections, automate administrative tasks related to managing the data, and then validate compliance with our assessment criteria. Do all the files have a required checksum? Are all the files still uncorrupted, i.e. the new checksum on a file equals the old checksum? But we also still wanted to automate analyses, being able to automate processing of the data such that a second person could come in and do the same analysis and get the same result. We came up with a definition for the practical policy as being an assertion or assurance that is enforced about a collection by the creators of the collection. So these are assertions that the people who assemble the collection are making. A person accessing the collection should be able to understand which assertions are made and what properties we're claiming about the collection itself. The groups applying the practical policy administration typically have to deal with issues of scale, hundreds of millions of files, and problems of distribution, managing the data across multiple sites, multiple countries around the world. Next slide. There were 3 outcomes from the Practical Policy Working Group. We developed a concept graph for explaining the topics behind doing policy-based data management. We developed policy templates, which were then applied at multiple sites, and we analyzed the policies from production data centers. So I'm going to go through these 3 topics. The first one then is going to be a description of the concepts used behind policy-based data management. So for the next slide, policy-based data management, we start with the idea that we have a collection, a set of digital objects that we're trying to manage and whose properties we want to be able to guarantee. Before we build a collection, there's always a driving purpose. There's some reason why we need to assemble the collection, either for preservation or for distribution or for publication or for processing, but there's some purpose behind the assembly of the data. Given a purpose, then there are a set of properties the collection needs to have. So if I'm doing preservation, I need to have properties of authenticity, integrity, chain of custody, etc. Given a property, then, we want to define a policy that will enforce the property. So the purpose and property are effectively the consensus of the community that's creating the collection. The policy that we develop is a computer actionable rule that the system will then use to enforce the required property. The policy controls the execution of a procedure. Procedure is composed from a workflow. The workflow is assembled from basic functions. Each time one of these functions runs, it generates some state information that we have to store persistently. So data management is fundamentally different from computation management in that state matters. We have to know what was done in the past. We have to preserve any information we generate today so in the future we can go back and see what was done with the data. Next slide. This slide fleshes out the previous slide. It's basically the same concept. We have a collection, which is managing digital objects. They could be files, workflows, images, observational data. Each digital object has a set of attributes that we can query. These attributes could be provenance information, descriptive information, administrative information. Given the purpose for the collection, we then get to define the set of properties, such as integrity, authenticity, or access control, that we want to enforce. We would like those properties to be complete, i.e. applied to every digital object in the collection. We'd like them to be correct, i.e. we're using the most recent version, and we want to make certain that the most recent version of a policy or procedure is applied to all the files within the collection. And it has to represent a consensus of the group that's assembling the collection. So if we take an integrity property, then we need to create a set of policies to enforce it. If I'm going to maintain integrity, I'm going to have to replicate. I cannot trust any storage environment, any operational staff, any institution. The only way I can ensure that a copy will be available is to have multiple copies at multiple sites with multiple types of storage environments under multiple administrative control. So I need a replication policy to do this. But I need to be able to verify that the files I've created are still good, so I need a checksum. I need a policy that guarantees a checksum will be provided with each file that's written into the system. So for that policy to work, it decides when and where I'm going to apply the procedures that do the replication, verify the checksums. Those procedures chain together basic functions. So I needed a function to actually do the data object replication. I needed a function that would actually create the checksum on the object or a current value for the checksum. And I can chain these procedures together into a workflow. Each time one of those functions is executed, it generates persistent state information I need to manage. So I need to associate with each file a data ID, also a replication number. I need to associate the location where the replica was put. I need to associate a checksum so I can go in and verify it. A user that interacts with this system from some client then has these policies automatically invoked through policy enforcement points. So at a policy enforcement point within the middleware that comprises the data management system, you put into a rule-based policy that will actually be applied, and then the system will automatically execute it as you do your actions from the external client. So the policies that are enforced are done independently of the choice of client in a policy-based data management system. In addition to policies that are automatically enforced, typically you need to be able to do periodic assessment criteria and go in and verify a property. So you have to be able to run policies as periodic rules. Next slide. The policy templates were developed in order to simplify the construction of policies. So within the policy template, we define the constraints that control the execution of a task. The constraints then depend upon a set of persistent state information against which the constraints are evaluated. So I might have a constraint that I need some number of replicas, and the persistent state information is the required number. So if I want 3 replicas, somewhere I've got to store the number 3. Given the constraints, I still need to specify the operations that will be applied, and the operations will also need additional state information. So if I needed 3 replicas and the operation is to create a replica, somewhere I have to store the information about where the replica may be placed. So the storage location is a type of persistent state information needed to execute the replication operation. So given constraints and the state information they need, and the operations and the state information needed to perform the operations, we can then define a template that describes what the policy is doing. So this is a very curious question. How many persistent state attributes and operations are needed? So I'd be very interested in understanding from your perspective the level of sophistication required by the system in order to enforce the properties, evaluate the policies, apply the operations needed within your environments. Just make a guess. Is it 10, 50, 100, 500? I threw Herman a curve by asking a question that wasn't in the original slide. So in practice, we looked at a wide variety of sites asking this question: what are the tasks you need to have performed? What type of properties do you want to have associated with your data? And so we'll look at this answer from the perspective of the data centers that we analyzed. So let's go to the next slide. So the Practical Policy Working Group tried to get an answer to this question. We looked at 11 types of data management systems across 30 institutions and made 2 test beds. We had one test bed based on the Integrated Rule-Oriented Data System running in the DataNet Federation Consortium, another test bed running at Garking Computer Center based on GPFS. But we analyzed responses from the 30 institutions and came up with the following list. These were the highest priority tasks that they believed they needed to have done. I rated each task. I gave the highest priority task a value of 10, the next highest priority task a value of 9, down as far as they went, and then added up the numbers for each task. So the ranking here is a arbitrary ranking, but it does indicate which tasks were requested most often and most frequently, or which tasks were of the highest importance to each site. So integrity was the #1 requirement. If the data are corrupted, then there's no reason to keep them around because they're useless. The second highest one is tightly related: preservation. We've got to make certain that we can keep the data, manage it across the storage systems. And then by the time you get to access control and provenance, you're starting to get to requirements that less than half of the sites thought were high priority. So there are a small number of very important attributes, but if you go down to the bottom of the list, there are still some things that some site needs, which is one of their top 3 priority items that made it to the list. So this is quite typical. There are typically around 10 to 20 types of things people want to have done for their collection, but there's a very long tail of properties that they need. So in practice then, the number of policies actually needed across all of the sites is over 100. Let's go to the next slide. So we took the top 11 policies specified by the data centers and implemented example of computer actionable rules for each policy area and published that data in 2 documents. One is the outcomes policy templates. This is basically the information required to implement the policy. And then the implementations document, which is an example of the actual policy that was run. So you can look in either book to see examples of policies that were developed for each of these different areas. Next slide. So this was the question that Herman originally brought up. Do these set of 11 tasks address your highest priority management issues? Which tasks are highest priority: integrity, preservation, or access control? So let's see your response. So we're getting the results of 8 people so far, and it's split. Half, well, no, now it's 60-40. So integrity is slightly winning over preservation. This is a trick question because preservation itself requires integrity as one of its properties. So if you're building a preservation environment, there are 4 fundamental things you've got to do. You've got to maintain authenticity, integrity, chain of custody, and arrangement. So integrity then could be thought of as part of preservation. But integrity is highly important within any data management environment. Next slide. So now the question was, given that we did this effort across data centers, there are other types of the environments that also need to manage data. So in this list, data centers are item number 4, but I have the requirements from people who are focused on sharing data, the people focused on publishing data, digital libraries, the people focused on preservation or management of protected data, or the NSF-style data management plans. And across, for each of these areas then, we defined, for each of these categories, we defined types of policies that would be needed. So they range from 11 policies for data sharing to 59 policies required to manage protected data. And we wanted to understand how many operations were required to implement all of the required tasks, how much state information needed to be managed such that those tasks could be done. So we did this assessment through the DataNet Federation Consortium and came up with the following. We ended up with 97 unique tasks across the 6 applications, requiring 50 persistent state attributes, applying a total of 123 different operations within the data management environment, and implementing 175 actual computer actionable rules. So these results are published in datafed.org under publications, articles, and white papers. And they describe a further set of analyses done beyond the Research Data Alliance Practical Policy Working Group. When we look at these policies and operations, we can then ask whether or not they really represent the generic set of operations needed within an environment. Next slide. So let's look at one specific area, protected data management. This was the area that defined the largest number of tasks. And what we did is analyzed an administrator's guide for the management of protected data, including data that included personally identifiable information or protected health information or credit card information. It turned out that the requirements for each of these areas were very similar. And then we asked, are the type of tasks you need to do for managing protected data similar to the tasks needed for managing a preservation environment? Obviously, if you put data containing protected information into your preservation environment, you should include the policies required to do the protected data. So let's look at them. We had 51 tasks we needed to do. And so these were organized around identifying the presence of protected information when data comes in, checking whether there are viruses or anything untoward coming along with the data, verifying that your passwords have the required strength in order to protect against unauthorized access, managing encryption of the data on transfer, managing encryption of the data in storage if it contains protected information, managing interactions with federations. If I put a copy at another site, can I guarantee that the same access controls are going to be applied at the federated site? And how do I make certain that every file is correctly replicated into this distributed environment? So there's a long list of activities that had to be performed for the protected data based on its content. The assessments really were done through generations of reports. Identify every time a data set was corrected, a change was made to it. Identify every time a person accessed the data so we can prove whether or not they had the required privilege in order to do that access. Next slide. So in addition to having policies that ran on ingestion automatically, there were a large number of policies that had to be applied periodically. Parse event trails. So you need to understand how the environment itself is changing over time. So it's not sufficient just to have state information. I need the event log to be able to track prior operations done within the environment. So this, one more set, next slide. So this is the third, last third of the policies for the protected data. They had a lot of policies related to data expiration. Basically, there are expiration dates on passwords, there are expiration dates on files. You have to be able to set lockout periods if you have too many unauthorized accesses, and then at the end of that lockout period, allow them to try again. So it's not only automating the enforcement, periodically doing the assessment, but it's also managing time-dependent periods related to different entities within the environment. Next slide. So these were the basic categories we had to use for describing tasks related to management of protected data. And in practice, these generic tasks really could be applied at every data center, whether or not there is protected data. So I still have to manage passwords. I still have to generate log files. I have to create state information to track each processing step. I have to manage the access controls, generate the audit trails, parse events, and verify. So in some sense, there are some generic operations that really should be applied within data centers. Next slide. One other area I'll go through very quickly were NSF data management plans. The National Science Foundation requires that every project provide a 2-page description of how data will be managed. In 2 pages, you can't specify very much. However, the NSF directorates did publish guidance, descriptions of the type of tasks they wanted done for data that were generated through project research. And each NSF directorate, unfortunately, provided a different set of requirements. So we analyzed 12 sets of requirements and identified 38 data management tasks that at least one of the directorates wanted done for data generated by research they funded. And these are published in the policy template workbook published by the DataNet Federation Consortium. So I'm going to look at these tasks briefly. They were tasks related to organizing the collection itself. What's the consensus behind how the collection is being assembled and managed? Will there be collection plans? Do you identify the types of instruments you're going to use? Do you categorize the data? Do you use existing data, and how is that integrated into your collection? They then had sets of tasks related to the analysis. How do you verify quality control within your environment? What types of processing are going to be done on the data? How is the data going to be shared while you're doing the analyses? Do you have standard naming? Do you have standard data formats? Do you have digital identifiers? Do you have standards for the metadata? Next slide. And then they had 3 more categories related to the actual storage of the data, the publication of the data, and the preservation in an archive. So for storage, they were basically interested in report information, size and location. For publication, they needed to understand when the data would be made public, whether data products would be made public, what were the constraints on reuse or redistribution, what are the access restrictions. These are typically time dependent. Data may be held proprietary initially, but then after some period it becomes public. What are the intellectual property right restrictions? What's the type of web access? How are the data shared, or how are code distributed? And then for the archive, they needed to know how long the data would be kept, what type of curation in terms of required descriptive metadata would be applied to the data, where would it be stored, what's the degree of security, how many replicas, how frequently are the data backed up, how frequently is the integrity checked, how do you manage technology evolution, where's the catalog stored, and do you manage data formats over time? So these were the 38 different tasks related to managing the data. In practice, the groups that submitted data management plans had roughly between 5 and 15 different tasks they were able to specify in a 2-page document. So none of the submitted plans addressed all of the issues. So I'm going to close with this slide. The Data Fabric Interest Group is the next step. We're very interested in 3 types of data fabric. The one that's currently being worked on is a data services fabric. They want to automate discovery and access to data through services that can be shared. So they'd like a standard for a data access service, a standard for a data discovery service, such that if your data center complies with that standard, then someone else will be able to come in and use, in effect, a generic data access service to get to it. But there are 2 other types of data fabrics. There's a data collaboration fabric. Can we build a system in which we actually share the namespaces for users, files, and workflows, such that the name you use to reference a person, a file, or a workflow is the same name I use? Then it makes research collaborations very easy. There's also a data interoperability fabric. How do we manage communication between the different systems? Right now, if you go through a web service, you're assuming asynchronous communication over HTTP, but I could be doing an asynchronous communication over a data bus. So how do we ensure interoperability through a common mechanisms to exchange information requests between the different components that are being integrated into the fabric? A second area of work is the Data Foundations and Terminology Interest Group. They would like to see a standard set of operations and a standard set of persistent state information attributes that are used within data management environments. There are multiple interoperability test beds that are being made. There's one, so EUDAT in effect is doing interoperability across multiple sites. There's 2 groups in the US working on this, a National Data Service and the DataNet Federation Consortium. So given a data fabric, there are multiple opportunities to test the validity and capabilities provided by the data fabric within these interoperability test beds. So I thank you very much for listening, and that concludes this webinar.